How can you use tables and graphs to show equivalent ratios? Think about this question during the lesson. Ellen is shopping for supplies at Jake's party store. Make a table to show how much Ellen will spend to buy 3, 6, 9, or 12 balloons. Then plot the pairs of values in a coordinate graph and use the graph to find the cost of 18 balloons. The ratio 3 balloons over $2 represents the cost of the balloons. You can make a table of equivalent ratios to find the costs for other numbers of balloons. Make a table of equivalent ratios to find the costs of 6, 9, and 12 balloons. What is the missing value in the table?
Select your answer.
Ellen can buy 3 balloons for $2, 6 balloons for $4, 9 balloons for $6, and 12 balloons for $8. Plot the pairs of values on the coordinate plane for each ratio, x to y. What ordered pairs represent the ratios in the table? The ordered pairs are 3, 2, 6, 4, 9, 6, and 12, 8. Connect the points with a dashed line. Why is a dashed line used instead of a solid line? What does the arrow indicate? A dashed line is used because you can only buy whole numbers of balloons in ratios of 3 balloons to $2. The arrow indicates that there is an infinite number of equivalent ratios. Now find the cost of 18 balloons. How do you use the graph to answer this question? Find 18 on the x-axis, and then trace the grid line up to find where it intersects with the dashed line. From there, move horizontally to find the corresponding value along the y-axis. The cost of 18 balloons is $12. Now you know how to use tables and graphs to show equivalent ratios.
What are the coordinates of the point that represents the number of balloons you can buy for $6?
You have your coordinate already drawn out, just like it is from the example. This one, however, doesn't have the numbers on the bottom. And here's the bottom. They don't have numbers written for each one, and they don't have numbers written here, but they are in the example in your book. But it asks us the coordinates for $6, so it's going to be two here, a 4 here, a 6 here. So it said for $6, what would be 2, 4, 6, and then 8 here, and then over here would be 2, 4, 6, 8. You can't really see that, but that's not the point. We have on the table from the example that there were 9 balloons, and it asked for $6. It was 9 balloons and $6. So on the graph, we'll find the 9. The 9 would be between 8 and 10, so that would be this point. And then it goes over to the $6, which is the cost. So we have the 9 and the 6. So our coordinates would be 9 first and then 6, because the x comes first when you're writing your coordinates, and the second number will come back to the second part. So you have, let me just write this as your x always comes first and then your y.
Nico is making juice. He has 25 celery sticks. If Nico uses all 25 celery sticks, how many apples will he need to make the juice?
Use repeated addition to complete the ratio table. So they've done that for us. We have 25 celery sticks he wants to make. Then it says he has 5 celery sticks for 2 apples. So here's the celery sticks and here are the apples. And then each time they're using the repeated addition. So plus 5, plus 5, plus 5, plus 5, all on the side for the celery sticks. And then for the apples, they're adding 2 repeatedly all the way down the table. So all they wanted us to do is to decide how many apples he would need to make the juice if he used all 25. And so once completing the table, 10 apples is how many he would need. And they also have graphed it here. The values of each of onto the coordinate plane. So we have 5 celery sticks to 2 apples. As you can see, the number of celery sticks at the bottom, so the 5 is first, and then the 2 is the number of apples, and that is second. And for each one, they have plotted on this number line along with that dashed line and the arrow that goes on infinitely forever for all the other equivalent ratios.
The diameters of different circular objects are given in a ratio table. What do you notice about the graph of the pairs of values given in the ratio table?
They've plotted the pairs onto the coordinate plane, and if we look at the graph, the points all represent the values from the table, and they have a linear relationship, means they are continuously going on this line, and that's what we're noticing. And that's all they ask is, what do you notice? So you just notice that they are the values from the table and that it's linear.
Can you draw an object with a diameter of 10 inches and a circumference of 50 inches? Explain.
To see if we can draw that object, we're going to graph it on the coordinate plane. So it has a diameter of 10, circumference of 50. If we look at the graph, we have diameter as the x value, so the diameter is 10. So that's going to be first. Remember, you always do x, then y, and so the y would be my 50. So these would be my coordinates. I'm going to look first on the x-axis for 10, and 10 would be about here because it's going to be counting by 10, 10, 20, 30, 40, and then 50. So that's 10 here. I'm going to just circle it just to identify that point. And then I have 50 on the y-axis, which is here on the y. So if I go up, to 50, my point would be here. That point is not on that line that we created from the example, so that that tells us it is not possible for that type of object to be created.